The Q400 uses one air conditioning unit located in the aft equipment bay to supply temperature and humidity controlled air to the cabin and flight deck. The unit consists of two air cycle machines. These ACMs are usually referred to as packs. On ground, the optional APU can supply bleed air into the air conditioning system, and the optional ground air conditioning supply can feed conditioned air into the cabin and flight deck ducts. There are also three small cooling fans for the avionics and LCD cooling system, two main and one standby, which operate automatically with no pilot input. This subsystem cools equipment in the avionics and wardrobe racks, as well as the five main display units on the flight deck. Output from the air conditioning system feeds into the pressurization system. Let's open up the air conditioning unit to give you an appreciation of how it works. Hot bleed air from the pneumatic system and the optional APU enters the air conditioning unit through the pack flow control and shutoff valve. It's then partly cooled in a primary heat exchanger by ram air. The airflow then divides into two paths to the compressors of two air cycle machines, which increase the pressure and temperature, and the flows are recombined before entering a secondary heat exchanger. From here, the cooled air passes through a reheater condenser water collector unit, which removes some water vapor and recycles it via a spray nozzle. The nozzle increases the efficiency of the heat exchangers and exhausts the water vapor overboard in the ram airflow. From the water collector, the air doubles back through the reheater, through turbine shutoff valves, to the turbines of the air cycle machines. At the turbines, it mixes with hotter air that bypasses the ACMs, regulated by these bypass valves. All valves, temperature, pressure and flow sensors are monitored and controlled by the electronics control unit, the same one that controls the pneumatic system. From the ACM turbines, the air enters a mixer, where it's mixed with recirculated air from the cabin. Next, it passes through the condenser again and is ducted to the cabin and flight deck distribution system. The airflow soon passes through a splitter duct. The splitter divides the flow so that most of the right ACM pack's output goes to the cabin and most of the left goes to the flight compartment. So the air cycle machines can be regarded as cabin pack and flight compartment pack. If the ground air conditioning option is installed, preconditioned ground air can be added here. And in the event of a problem with the pressurization system, ram air can be vented to the distribution system. The conditioned air supply is distributed to the cabin and comes out at the lower panels, at the upper gasper nozzles, at the ceiling upwash and the wall downwash outlets. During heating, about 70% of the warm air comes from the lower and 30% from the upper outlets. During cooling, the situation is reversed. About 30% of the cool air comes from the lower and 70% from the upper outlets. A distribution damper under control of the ECU is responsible for the split. On the flight deck, the conditioned air warms your feet, keeps you alert, and demists the side windows, so you have a nice view. Cabin and flight deck air is recirculated to the air conditioning unit, assisted by an electrically powered fan. Let's look at how this cycle is controlled on the air conditioning panel. Remember from the pneumatics lesson that the bleed control switches control bleed air output from number 1 and number 2 engines via the high pressure and nacelle shutoff valves, and that the bleed control selector regulates bleed flow through the nacelle shutoff valves. The recirculation fan starts in low then changes to a higher speed on command by the ECU. The duct or cabin selector linked to the temperature gauge can be switched to display temperature in the cabin duct or flight compartment duct or in the cabin itself. The ACM pack switches control the two air cycle machines and have three positions. Off. The ACM is switched off by closing its turbine shutoff valve. Manual. Only the analog channel of the ECU controls temperature for its ACM. And the normal auto. The digital channel maintains a constant temperature by regulating the pack flow control and shutoff valve. In both auto and manual, you adjust cabin and flight compartment temperatures with these knobs. Temperature control is achieved by modulating the ACM bypass valves to add or take away hot bleed air at the turbines before the mixing box inlet. For auto, the ECU digital channel uses zone temperature sensors to compare actual and requested temperatures. But for manual, the zone temperature sensors are not used. However, keep in mind that this is an interconnected system, so changes in the flight compartment will have a delayed effect in the cabin, and vice versa, so you should avoid excessive temperature changes. In auto, you can hand over control of cabin air conditioning to the flight attendants by turning this knob to the FA position. Touch the cabin temperature selector to move it to the FA position. Cabin temperature is then controlled entirely from the flight attendant panel. On the panel, there's an LED to indicate that the flight attendant has control of cabin temperature, and the digital readout shows current mid-cabin temperature in centigrade or Fahrenheit. To increase or decrease cabin temperature, the flight attendant presses these arrow push buttons, and the requested temperature is indicated by this bar. On the flight deck, you can control demisting of the side window and airflow to the low-level vents with these levers on both side walls. Let's look at normal flow control using a simplified diagram. In normal operation, input of bleed air is regulated by the bleed 1 and 2 switches, which control the nacelle and HP shutoff valves, the bleed flow control switch, which controls flow through the nacelle shutoff valves, and of course the pack flow control and shutoff valve, controlled by ECU channels via these switches. The bypass valves regulate the amount of hot bleed air which bypasses the air cycle machines, and are controlled by the cabin and flight compartment cool-warm switches. Flow to the ACM packs is controlled by the pack flow control and shutoff valve and by turbine shutoff valves, operated by these switches, and of course by the electronics control unit. But what happens in abnormal conditions? Firstly, if there's a problem with an ACM pack, or you switch it off, its turbine shutoff valve will close, and its bypass valve will close. Of course, the ECU digital channel in control will still regulate the pack flow control and shutoff valve, giving normal output. In this situation, even if the recirculation switch is off, the ECU will operate the recirculation fan at low speed. A second abnormal condition. If one digital channel fails, or if you select manual, its analog channel will operate its bypass and turbine shutoff valves, and the other digital channel will take over control of the pack flow control and shutoff valve. But if both digital channels fail, because the pack flow control and shutoff valve is only under digital control, it closes, and both ACM packs will be shut down due to a lack of airflow. All other valves will close, and you'll need to descend and use emergency ram air ventilation. Now, air conditioning cautions. If the ECU triggers pack hot cautions, it will automatically shut down the affected ACM pack. This is different from the 100, 200 and 300. You should switch off the pack. Touch the pack flow control selector and switch bleed air to max as a precaution to give increased bleed to the remaining pack. Monitor the situation carefully. Similarly, if temperature in a duct goes above 87 degrees centigrade, you'll get duct hot cautions. Verify the overheat on the gauge and take the same actions. With both packs shut down, you need to descend and use ram air ventilation. Finally, if any two of the three avionics and LCD cooling fans fail, you'll see the Fans Fail advisory at the bottom of the engine display. The remaining fan will cool all the equipment. Single fan failures are recorded but not announced. If you get Fans Fail on ground, you'll also see the avionics caution light, and it's a no-go item.